This is the lesson for Chapter 9, Section 1, titled Quadratic Graphs and Their Properties, day number 1. And so first thing we're going to look at is what a quadratic forms, the graph it forms. And so like linear functions form a straight line, quadratics form a U-shaped graph called a parabola. So here it talks about a quadratic function is always in this form where a cannot be 0, it says, and notice how the x value is to the second power, and everything else is just to either the first power or 0 power. So x is to the first power here, c is to the 0 power, and we don't see the power because we can rewrite this as x to the 0 power, where x is to the first power over here. So basically a quadratic function is in this form where we have x to the second power. And what that'll end up making is a U-shaped graph, and we're going to see that today. So here are some examples of quadratic functions. Notice how x is always to the second power. And then here we can have an x to the first or an x to the 0 over here. Well, the simplest form of quadratic is considered the parent graph form, and so that looks like this. Now we can use the function notation, this function notation here, or just y, and basically that represents the y-axis or the range values. X represents the domain values, and it's also our inputs. And you'll notice that with a quadratic we have symmetry, and so if you cut right along the y-axis for this one here, we could end up taking this graph and folding it, and it would fit perfectly on this graph other side here. And so notice that if you go over one space, we can go up one space. And the reason is that when we go ahead and look at the graph here, and let's say we had y equals x squared, and if I pick some x values and I plug it into the equation and come up with y values, watch what happens. So if I have negative 2, you see you square negative 2, and you get the same answer you do if you square positive 2. And so when I square that, I end up with positive 4. If I square negative 1, I get the same answer I get when I go ahead and square positive 1. And notice again that makes 1. And if you square 0, well, there is no opposite of 0, and so that's just going to be 0. And that's what we have here. You see, if you go over 2 spaces to the left, you go up 4 spaces. 2 spaces to the right, you go up 4 spaces. And that's what makes this symmetrical, is the squaring action of this. And so those are the 4 points, actually 5 points, that they use to be able to draw this graph. And that's kind of what we'll be doing on our assignment. But before we get to that, we're going to end up having to name some components of it. So we have what's called a vertex on a parabola, and that's kind of where it changes direction. And so here, at this example, the vertex is this point right here. Here the vertex is this point right here. And these are two different types. You see, this one we say opens down. Opens down. And the reason it opens down is because, as this one here says, actually it's going to be this one, a is going to be less than 0. So basically what we had here is a y equals a negative ax squared for this equation here. So whenever we have a negative number in front of the variable x squared, it's going to end up opening down. And this one has a vertex again at this point here, which we'll go ahead and name, which is 0, 3 is the vertex. And then they also want us to tell, is this a minimum or a maximum value? Well, this is a maximum value. It's a maximum whenever we have the graph opening down, or when a is negative. This one opens up. Opens up, and we see that the vertex here is 1 space to the right, 1 space down. So we'd say the vertex equals 1 to the right, 1 down, so 1, negative 1. And this one is a minimum point. It's a minimum point because it's as low as it goes right here. It doesn't get any lower, and so that's why they call it a minimum point. So we'll see that we always have a minimum point when we have the x squared term as positive. So this one had an extra component added on to it, the bx plus c, to get the vertex to this point. We'll see that later on, but basically we need that a term to be positive. So I'm going to draw that arrow a little bit further over. And so whenever this is a positive term, positive x squared, that's going to end up opening up. And so we'll see that with these. And for this first one here, again, we're identifying the vertex of each graph, then tell whether it's a minimum or maximum. So the vertex is just where it starts to change direction. So it looks like it goes by 1, 2, 3, 4. So these are going by 1s, and these are going by 1. So it's 1 space to the right, 3 spaces down. So the vertex for this one is 1, -3. And this is a minimum point because it's as low as it can go. This one looks like 2 to 4, so this would be 3 over to the right and 1 down. So the vertex here is a 3 right, 1 down, and it again is a minimum point. It's a minimum whenever we end up having the lowest value possible. And this one's a maximum point, but I'll find the vertex first. So the vertex here is 1 to the right and 1, 2, 3, 4, 5 spaces up. So 1, 5, and this is a maximum point. So it's important to understand that concept of minimum and maximum, so it helps us when we're graphing it. And again, to realize that whenever we have a positive x squared term, it's going to open up. Negative x squared term is going to end up opening down. And we get to experience that with these next few problems. We get to graph. So the way we're going to graph these is we're going to just pick some values until we understand the concept. But I think we'll pick up the concept pretty quickly. So this is the function, 3x squared, and then this is the y value. So I'm going to start with some negative values. I'm going to start with -2. And when I go ahead and plug that in 3 times, but I got to square first. So -2 squared makes 4. 4 times 3 makes 12. But I'll get the same thing with +2. So you can see how whenever we plug that in, a number in, it's going to give us the same value if I plug its opposite because I have to square that number. 2 squared is 4 also, so that gives me 12. So notice that whenever we do a negative value or a positive value, it comes out to the same answer in these cases here. Because when I square a number, I get that same value. So same thing with -1 and 1. You'll see the same thing occurring. So when we plug in -1 in for x, we square it, we get +1. Times by 3 gives me 3. So same thing with a +1. 1 squared makes 1 times 3 makes 3. And then 0, well, that's just going to cancel out the 3, and that makes 0. So when I plot this, I go over 1 space, or over 2 spaces to the left, up 12. Well, I can't quite get there, but I know it's going to be way up in this region here. So what I might do, let's see if I can do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I'm going to call this my x-axis. So I'm going to modify this graph a little bit, call this my x-axis, and I'm going to put the 0, 0, this origin point down here. Now, I'm going to just graph the positive sides, 2, 12. So over 2 spaces up 12. So this is 10, 11, 12. And so I'll just put in a couple marks here for extra values so you can see where that is. And there's one exactly opposite of that on the other side because there's symmetry involved here. And then over 1 space to the left, and then up 3 spaces, 1, 2, 3, then there's going to be one exactly opposite of that. See how it's +1, 3. So we've got symmetry involved, which helps us graph these points. It seems kind of daunting. We have to graph 5 points, but because of the symmetry, it makes it easy. And so this is what that graph looks like. Now, instead of changing the values of the intervals, I decided to leave it as a 1-to-1 because I want you to see how steep that is compared to maybe this first graph that we ended up seeing when I graphed, and I'll come back to that right now to show you. So you can see how much wider this one is compared to the one that I just ended up doing over here. So this one's much more narrow because it has to go up much further because I'm multiplying by that 3. So let's see what happens with this one. I've got some inputs I need to come up with. My rule is -2.5 times by x squared. And then I'll come up with some y values, some outputs. And so notice again, when you plug in -2 or 2, you're going to get the same value. So -2.5 times by, and it doesn't matter whether it's negative or a +2. When you square -2 or +2, you get 4. And then 4 times by 2.5, well, half of 4 is 2. 2 times 4 is 8. So adding those together gives me 10. And it's negative because I'm multiplying by that negative. So it was a positive when I square, but then when I multiply by the negative, it gives me a negative. So either one is going to give me negative 10. So again, if you plug in negative 1 or 1, you're going to get the same value, because negative 2.5 times by plus or minus 1, whether you square 1 or square negative 1, you get the same number, 1. Times by negative 2.5 gives you negative 2.5. Plugging in 0, well, that's just going to cancel out this squared symbol, and it's going to cancel out that 2.5 also, so we get 0. So I'm going to do the same thing, call this the x-axis, and again, I have that point at 0, 0. That's the vertex, and then negative 1 or 1, I go over or go up 2.5 spaces. So over 1, up 2.5 spaces. So last time, I ended up having to go up 3 spaces, so that was more narrow because I had to get up there. This one's going to be a little wider because I'm only going up 2.5 spaces, but still fairly narrow. And the next point is over 2 up 10. And again, due to the symmetry, I know that the other point is right there, and that's what makes this fairly quick. See, if you can get away with just coming up with 3 numbers, then you've got what this graph looks like, because once you draw half of it, you know the other half is going to be the same. So that's kind of what that graph looks like, smooth curve through those points. So here we have 1/3 x squared. So when I take a third of a number, well, it's going to make it much smaller. See, when I multiplied by 2.5, it made the number much bigger. When I multiplied by 3, it made the number even bigger. But now I'm going to be cutting it by a third, and so that's going to make it smaller. So whenever you multiply by a third, that's like dividing by 3. So whether I plug in negative 2 or positive 2, I'm going to get the same answer. So times by, and then negative 2 or positive 2. Squaring that gives me 4. 4 times a third gives me 4/3. So that's only going to be 1 and 1/3. Where, look at the other numbers. When I multiplied by 2.5, I got to 10. When I multiplied, oops, I made a mistake on this one, I see now. I was supposed to go down 10 spaces, so I'll fix that real quick. So on this one, I ended up having to multiply by 3, and I went up 12 spaces. So I'll come back and fix this one. I see where my error was. Instead of going up 10 spaces, I should have gone down 10 spaces. So let's actually go ahead and fix that before we go too much further. So coming back to this graph, now I've come up with a new one here. What I need to do is I need to put the x-axis up top rather than down below. And there's my x-axis. My y-intercept, again, is right there at 0. And again, I'm going over 1 space, and then I need to go down 2.5 spaces. So it's going to end up going right about there. So it's 1, 2.5 spaces. So again, the symmetry allows me to come up with other points pretty quick. And then over 2 spaces down 10 spaces. So again, not as narrow as that first one, but still fairly narrow. But this one, what's different is it's heading down. It's opening down because of that negative sign in front of the x squared term. And so that's what I should have done the first time. So something to note, make sure you don't make that same error I did. So let's take a look at this one, back to it. So again, when I take a third of a number, it got really small compared to being bigger. And if I take negative 1 or positive 1, plug it in for x, either one I end up with getting 1. Squaring 1 or squaring negative 1, you get 1. 1 times a third just makes a third. And so either way, you get 1/3, whether you plug in negative 1 or positive 1. At 0, well, that's just going to cancel out that x squared term, and third times 0 makes 0. So I could go ahead and use the actual graph that they gave me here. So I'll put that 0, 0 at this point, and then over 1 space up just a third of a space. So I just have to go there. So not very high up, just up a third of a space, not even 1/2. And then over 2 spaces up 1 and 1/3. So I'm right there. So you can see when you multiply by a third, it gets very wide. So very wide when we end up multiplying by a fraction, very narrow when you multiply by either a negative number or positive number, but as long as it's bigger than the absolute value, if it's bigger than 1, it's going to get more narrow. So again, remember that rule. Don't make the same mistake I did. This negative sign here tells us that it opens down, and a positive, so this was positive, a 1/3 tells us the positive sign there is the key, tells us that it opens up. And we'll be dealing with more the narrow and the wider portions, talking about those a little bit more tomorrow. Good luck on tonight's homework.